This video is a part of the program AI/ML that I do at Outcome School. So for today, our topic is tokenization in large language model, and that is something we'll try to understand with the example as well, as always. So here what I have done is that I have overly simplified the LLM architecture so that you focus on what? The tokenization keyword exactly, right? Now, so let's try to understand this. So suppose this is our sentence, Outcome School teaches, right? And then we will have the process called tokenization, and that is the center of this video, okay? Then we will have the GPT architecture like this, GPT, in that we will do a lot of things. So what we do is that we take this sentence, Outcome School teaches, we do the process of tokenization, and then we feed this into the model, the GPT actual architecture, right? And then from there something like this it will come out. So Outcome School teaches AI, right? So that is something we will try to see how that is happening. So one thing that I want to highlight today is that, and you all have to focus now here, so machines are very good at numbers because the machines have to perform the mathematical operations, and because of that they need the numbers, right? And because of that we will convert this sentence into some numbers, and that is what we do in the tokenization, and we will see how we are doing that. Okay, now, so there are multiple ways to do that thing, right? So there are multiple ways. So first one is the words, second one is the subwords, and then we have the characters, right? So there are other problems also that tokenization solve, but we will focus on what we are trying to learn today. Okay, now, so this is at the word level. So we will have the example sentence like Outcome School. So we will have two words like this. Then we have something called byte pair encoding, which is largely used by most of the companies like OpenAI as well, and they have in fact the library called tick token that will help you in converting into the subwords. So here you can say that, okay, out, come, SCH and OOL. So these are the subwords. Here our Outcome School sentence is divided into subwords like this. So now at the character level, right? OUTCOME. So you can see that here we have the division at the character level. So these are the ways to do, but generally we follow this by using the library called tick token, right? So this is a byte pair encoding. You can check the library as well. Now let's try to understand the complete picture. So here we have the sentence Outcome School teaches, and now what we will do as a first step in the tokenization is that we will break it down into the subwords in this example. Okay, so here we have the out, come, SCS and so on, so right. Now this is a tokenized text, so we have created the small subwords for that sentence. Now what we will do, we will assign some number and they will be unique. So out will always be represented by 436. Similarly, T will always be represented by 481. So these are just the numbers, right? So we can use some library. Those library will be called as tokenizer. So tick token is one of the example. So that library will go through the data set that you have, and that will create the vocabulary, right? So this is the vocabulary that we have, right? So like this, and then they will have the mapping file as well. So basically the mapper, text to ID and ID to text. So basically we can go from here to here, or we can go from here to here, right? So it is up to us. So based on the use case, we are going to use both the methods, text to ID or ID to text. So like that we do. Now these numbers, so these are the numbers which we actually feed into the GPT model, right? So this is the GPT model, in that we feed, and ultimately what do we get? Again we get the token ID, right? We do not get the text, we get the token ID. So for example, we got 26, and again we will ask our same library, because that library has a vocabulary and that has the mapping as well. So we will ask, can you convert 26 into the text? So it will say, okay, AI is a text for that. So that is how we get the complete sentence. Outcome School teaches AI. So this is the complete flow how the things works when we consider the tokenization. So numbers feed it into the model and we get the number from the model, and then we do the reverse mapping of that, right? Now it's time to see the same thing through the example, and here I have considered that I will go with the raw code. I'm not going to use the tick token libraries because it will put some abstraction. So it is a good idea to understand from the raw code and then go and use whatever you want to use for your use case, right? Now, so this is the data set that we have, as you can see, right? Now we have a method. So this is to separate the dots. So for example, here if you see that at the end of the sentence we have the dot, right? We will try to separate it out so that we can do the tokenization, right? So this method will help us doing that. So here you can see that the dots has been separated right here. Particularly you can see she composes songs and practices piano daily, space dot we have, right? So this utility function will help us doing that separation of the dots. So now we will create a vocabulary so that we can put all the unique words that we have in our data set. So we'll iterate on the data set and we'll keep on adding inside the vocab set that we have created here. Now, what we will do that we will display all the token to the word mapping that we have created. So once you print that, you will see something like this. 0 represents dot, 1 represents he, something like this you can see here. Right? So we have 70 words ID to mapping, as you can see, right? So then you can create the methods like this. You can convert text to token IDs, token ID to text. So these are the two methods that will help us in converting the text to token ID and the token ID to the text. So these are the helper method that we have created here. Suppose this is our example. She composes songs and practices piano daily, right? So now what we can do is that we can simply feed this particular sentence into the text to token IDs and we will see that numbers are coming out from that. So this is what I have printed here. And we can do the reverse of that as well when needed, right? Now we will feed this token ID into the token IDs to text. So now when we print, we will get the reverse of that exactly as we can see here. And once again, I must highlight, I have done the simplification so that we focus only and only on the things which are important to understand the particular concept. So few days back, I have done the YouTube live session where I overly simplified LLM, RAG, MCP, agent, fine tuning and the quantization. So make sure that you check that video as well. And I'm 100% sure that you are going to enjoy a lot. And most importantly, you are going to learn a lot of things from that particular video. And now you have the complete picture of where this particular tokenization fits into the complete architecture of the LLM, right? I will want you to explore more. So for that, what you can do is that you can explore how the choices between this and this can impact the model performance. So when I get time, I will try to create some videos on that as well. So for that, keep watching this Outcome School YouTube channel and I will see you in the next video.